Hello everyone, my name is Sultana Ijwana Haq. I am from Department of Applied Sciences, Guwahati University. The topic of my poster presentation is optical and structural characteristics of pani-capped lead sulfide nanoparticles. In this paper, we have synthesized lead sulfide nanoparticles with diameter in the range from 26 nanometer to 58 nanometer by changing the concentration of conducting matrix polyaniline in a non-acidic medium. A one-pot synthesis method is taken in this process. We have confirmed that the nanoparticles are formed by using various methods like UV visible spectroscopy, PL spectra, XRD, SEM and TEM analysis. The influence of concentration of matrix element on optical and structural properties of lead sulfide is analyzed and summarized. First of all, what is lead sulfide? Lead sulfide is a 4-6 semiconductor. It has various applications in infrared detectors, photo-optic applications, and gas sensing of various gases. Generally, the bulk lead sulfide has a narrow band gap of 0.41 electron volt and its absorption edge is 3020 nanometer. So, to make nanoparticles, the band gap should be larger than that of the bulk lead sulfide. The absorption edge should also be blue shifted. The synthesis method. For synthesizing of lead sulfide nanoparticles, we have taken pani, which is polyaniline by polymerization reaction. We have added water to pani and then we have added lead nitride solution to it. After adding lead nitride, we stir it for 3 hours. After that, we have added sodium sulfide dropwise, and finally the lead sulfide nanoparticles is formed. To analyze whether the lead sulfide nanoparticles are formed or not, we have used some methods, analytical methods like UV visible spectra, PL spectra, XRD, SEM and TEM. From UV visible spectra, the absorption edges, we can see in the figure that the absorption edges of the samples lie in the range from 330.75 nanometer to 427.37 nanometer. The blue shifting of absorption edges as compared to the bulk lead sulfide showed the formation of nanoparticles. Comparing among the 5 samples, we can conclude that with increasing in the concentration of the matrix element, the band gap decreases up to sample 3. Then it increases for sample 5. In PL spectra, you can see that the peaks are in the range from 338 nanometer to 586 nanometer. By increasing the matrix concentration, the PL intensity increases and it indicates the more excitonic recombinations. From XRD spectra, you can see that we have taken sample 1 and sample 5 for XRD analysis. From the graph, you can see both the samples are crystalline in nature. By comparing with JCPDS data, we found that the Miller indices of both the samples are as shown in the figure. The average crystallized size for sample 1 is in between 28 to 35 nanometer and for sample 5 is 50 nanometer. SEM analysis, you can see that the particles whose diameter are ranging from 45 nanometer to 57 nanometer can be observed. From EDS, it is confirmed that in lead sulfide nanoparticles, the high presence of lead and sulfur is there, including nitrogen, oxygen, sodium and carbon. From the 10 images, you can see that almost spherical shape of nanoparticles are formed, as they have almost similar sizes. As the scale is changing from 5 nanometer to 200 nanometer, it can be visibly seen that nanoparticles have been formed. We can also find the interatomic spacing with the help of 10 images. In conclusion, from this analysis, we concluded that lead sulfide Pani nanoparticles have been formed. The band gap values of the samples are larger than the bulk lead sulfide sample. Band gap decreases with increase in the matrix concentration. Size of the nanoparticles decreases with increases in the absorption edge of UV visible spectra. From PL spectra, we can conclude that the emission peaks are redshifted as compared to the bulk lead sulfide nanoparticles. From XRD SEM and TEM, we can confirm the formation of lead sulfide Pani nanoparticles. And in acknowledgement section, we would like to thank SEF, Department of Instrumentation, and USIC, Guwahati University for providing XRD data, for Department of Chemistry, Guwahati University for providing SEM analysis, for IIT Guwahati for TEM analysis, and Department of Bioengineering, Guwahati University for UV visible spectra. We'd also like to thank Mighty Government of India under YFRF scheme for granting us some fund, and these are some references. Thank you very much.